Let's take a look at graphs of logarithm functions in order to get a better understanding of how those functions behave. So let's take a look in particular at the graph of the function log base 2 of x. So we can start by constructing a table of values to help us graph it. And I'm going to pick some values for x that are going to be easy to compute. So let's say I start with x equals 4. So I want to calculate log base 2 of the number 4. So what does that mean? It means I want the power of 2 that will give me 4. And so the right answer for that, the right number to fill in here, is 2. Let's say I want log base 2 of 2. So now I'm asking what is f of 2 is log base 2 of 2. So what power of this base gives me this number? And the right exponent to fill in is a 1. So log base 2 of 2 is 1. Suppose I want log base 2 of 1. So what power of this number gives me this number? And the right exponent to fill in is a 0. How about log base 2 of 1/2? So what power of the base do I need to get 1/2? And since we see that this is a reciprocal of 2, to get a reciprocal, I want a power of -1. And I'll leave the last one to you to do on your own. Log base 2 of 1/4 is -2. So I picked values for x to plug in that would make it fairly easy to evaluate the function, but you can plug in other values too. For example, x equals 5. That would mean you're evaluating log base 2 of 5. And we'll see later how you could do that on a calculator, and if you do, you get an answer of approximately 2.3. So you can plug in lots of different numbers and use that to generate a graph of the function. And here's a graph for us. For example, if we see the point with x coordinate 1, y coordinate 0, that's right here, this intercept. And the point with x coordinate 2, y equals 1, that's right here. Now, let's observe some things about the graph here. The x-intercept is 1. If we plug in large positive values for x, values that are over here, the function keeps increasing, so plugging in large positive values for x produces large positive outputs. If I plug in small values for x, I get outputs down here on the graph that are large negative numbers. So putting in small positive values for x produces large negative outputs. And notice that there's no graph over here at all. We cannot plug in negative numbers at all. Another way of saying that is that the domain of this function is only positive numbers. You cannot evaluate the logarithm of a negative number. In fact, notice that this is a round parenthesis, not a closed bracket, so we're not including 0. What I'm saying there is you are not allowed to calculate log base 2 of 0, and that's because if you did, you'd be trying to solve this exponential equation. What power of 2 gives you 0? And there's nothing you can fill in this box that will work. 2 raised to any power is going to be a positive number. It might be very big, it might be very small, but it'll never give you 0. And so this does not exist. You cannot evaluate log base 2 of 0. And similarly, you can never get a negative number out of an exponential, so you can never take the logarithm of a negative number. So these 4 facts we've seen from this picture are true for the log base 2, but they're actually true for other logarithms as well. For any logarithm with any base that's at least greater than 1, all 4 of these properties are true. The x-intercept will always be at 1. Plugging in large positive values will give you large positive outputs. Plugging in small positive values will produce large negative outputs. But you cannot plug in negative inputs.